in your text. And in problem 50, they were talking about a horizontal pipe contains water at a pressure of 110 kilopascals, so that's 110 times 10 to the third pascals, flowing with a velocity of 1.4 meters per second. It's a horizontal pipe, and so it's just straight along, but then it narrows to 1/2 of its original diameter. So this is half the diameter if this is diameter D. I'm more a numbers type gal, so I'm going to say D is equal to 5 centimeters and just work with numbers. It's really, they drop out in the long run. So if I did this is 5 centimeters or 0.05 meters. I can set up the equation of continuity, A1V1 equals A2V2. So pi times 0.025 squared times 1.4 meters per second would equal pi times 0.0125, that's half of that, squared times V2. Again, remember the area is pi r squared. I got V2 to be 5.6 meters per second. And then for part B, it asks you to find the pressure of the water. So I could again use Bernoulli's law. P1 plus rho 1/2 rho V1 squared plus rho G H1 equals P2 plus 1/2 rho V2 squared plus rho G H2. And the height part can cancel out because it's just along a straight center line. We're not looking at a big height differential. The pipe's not going upstairs or something. And so P1 was 110 times 10 to the third pascals plus 1/2 the density. This is just water, so the density would be 1,000 times our initial velocity of 1.4 meters per second squared will equal P2 plus 1/2 1,000 times 5.6 meters per second squared. From this you can solve for P2 to get, I believe, 95.3 kilopascals. If I can read my handwriting correctly. Next we're going to look at problem 54. And this is an easy one, but this is definitely an excuse me, AP type problem where you've got your big water tank, or like I like to call it, the vat, and it's sprung a leak. The speed of the water emerging from the hole, if the leak is 2.5 meters below the surface of the water. So this height differential is 2.5 meters. Sorry, it's passing periods. Which is open to the atmosphere. So this is P naught, this is P naught. Guys, do we remember this equation of thinking about, hey, we've got some PE up here, we've got some KE here, we got to set those equal. Remember, Bernoulli's law is just a statement of the energies per volume. So rho G H1 equals 1/2 rho V2 squared. And how I can get to this, a couple of things. P1 equals P2, which equals P naught. So the pressure cancels in both spots because both are open to the atmosphere. And the other assumption I'm making is that the A1 is much, much bigger than A2. So we are assuming that V1 can be approximated as 0 velocity. Just saying that the water coming out the hole would be moving much, much faster than the sinking water level of the container. So from that, I got my densities to cancel. So I did 9.8 times 2.5 equals 1/2 v2 squared, and I get that velocity to be 7 meters per second. The last problem I wanted to go over for fluids is problem 57. And in problem 57, we're looking at a roof with winds being blown at a speed of 57.7 meters per second across a flat roof with an area of 668 meters squared. And they want to find the force exerted on the roof as a result of this wind. And so in order to do that, I used Bernoulli's to get the pressure differential. Where the heights cancel because they weren't changing. And so P1 plus 1/2 rho times 47.7 meters per second squared is equal to, I'm saying this is part 1, this is part 2. The density of air I found in your text to be 129. Kilograms per meter cubed. And this would equal P2 plus 1/2 rho. Inside the car, we're going to assume just that this velocity is 0. So that part kind of cancels out too. So I have the differential in pressure equals 1,467.6 pascals. And that's what I got for taking the difference between P1 and P2. And if I set that using pressure as the force per area, and I know the area is 668 meters squared, I was able to find the force to be 9.8 times 10 to the 5th newtons of force. Now what direction would that moving? This thing, faster moving fluid, creates a low pressure region. So the stationary fluid would create a high pressure region, and the force would always go from the high to the lower pressure. So this would be upwards because the faster moving fluid is moving over the top of that. Thank you very much for your time. Have a great night.